So in the last class, we have completed the conjugate and its properties. And today we are going to do one more concept, that is modulus of a complex number. So first we define what is modulus of a complex number. Just check here. Let Z is a complex number we have as A plus iota B. Z is given as A plus iota B. That is the complex number we have. Then if its modulus we want, then modulus is nothing but under root of A square plus B square. Modulus of the complex number, this is complex number A plus iota B, then its modulus will be going to define as, first it is denoted by modulus Z, and it will be defined as under root of A square plus B square, which is always a greater than or equal to 0 quantity, so never come out to be negative. That's why we are counting that as a modulus of complex. So if you have a complex number Z is equal to A plus iota bar B, then modulus of the complex number will be taken as under root of A square plus B square, and this is always a greater than 0 quantity or equal to 0 quantity. So this you should keep in mind. For example, if I say one complex number 3 minus 4 iota, and if I say you write down the modulus of it, when you take the modulus of it, it will come out to be 3 square plus minus 4 whole square. Then we will solve this as 9 plus 16, 25, so it will come out to be 5. So modulus of complex number will be 3 minus 4 iota. If I take, that will be modulus of Z is under root 3 square plus 4 square, that will be 5. One more question please. Find the modulus of minus 5 minus 4 iota. Find out modulus of minus 5 minus 4 iota. Find out. Please find out. Very simple question.
Root 41.
Root 41, yes. Is it root 41?
Yes, sir.
It is simple. Modulus of Z, when I am going to take, it will be under root of minus 5 whole square plus minus 4 whole square. So it will come out to be root of 25 plus 16 root of 41. So this is the modulus of complex number. Now coming on properties of complex number. Now we are coming on next part, that is properties of complex number. First thing which we have defined here is Z is equal to A plus iota B is a complex number. Then the modulus of this complex number will be denoted by modulus Z is equal to under root of A square plus B square, which is never come out to be negative. So this was the first concept we have developed today, and now we are going to come on properties of it. Properties of this modulus of complex number. First property says that if modulus of Z for any complex number is 0, if modulus of Z is for any complex number is 0, this implies Z is 0 plus 0 iota. You have to prove it. Modulus Z is 0. This implies Z is 0 plus 0 iota. We have to prove it. So how we do it? Z is equal to
Z square.
A plus iota. When you go for modulus of Z, it come out to be root of A square plus B square. And in the question, it is given that this quantity is 0. When this quantity is 0 means I got it A square plus B square is coming 0. And if a square plus b square is coming 0, square of two numbers can be 0 only when a and b individually has to be 0. So this implies a is coming 0 and at the same time b is 0. And if a is 0 and b is 0, that means what is our complex number? 0 plus 0. So first property says that modulus of complex number if come out to be 0, it will be complex number will be 0 plus 0 iota. That is a compulsion we have. Second property. Second property says that if you take modulus of a complex number is under root of a square plus b square. And then you take modulus of minus z, that is additive inverse. And then you take modulus of the conjugate of complex number. You will find all these three come out to be same. Z is given as a plus iota b. Then one thing is clear, minus z will be minus a minus iota b. And then z bar if I take it will be a minus iota b. When you think about modulus z, already known as root of a square plus b square.
Excuse me, sir.
Yes.
Sir, over there you have written z equals to root a square plus b square.
Modulus,
out in the left one. So it is a complex number or mod of it?
Modulus, yes. So modulus z is given under root a square plus b square, z is a plus iota b. Then we have minus z, so we will write this as under root of minus a whole square plus minus b whole square come out to be root of a square plus b. And third one, z bar, that will be conjugate, that will come out to be a square plus minus b whole square. So this is also come out to be a square plus b square. So I got it, modulus of complex number, modulus of its additive inverse or the conjugate. All three come out to be same. This is property number 2 we have. Third property note here. Modulus of a complex number, we know it is a square plus b square under root. Now it is clear that this quantity always come out to be greater than or equal to a. Because a, if it is coming 0, then it is simply a, so it can be equal. But if it is not 0, it will be always coming greater than a. So one condition is this. Second condition says root of a square plus b square is also greater than b. That means now one thing we have already got, that is modulus of a complex number always come greater than real part of z. Also modulus of z is always greater than or equal to imaginary part of z. So modulus quantity is always greater than its real part as well as the imaginary. Next property please. Next property already we have done, but we have not completed that time. In the conjugate I told this property to you. That property was this: if z multiply with its conjugate. If z multiply with its conjugate, then it will come out to be a plus iota b and a minus iota b. Now when you solve it, it will come out to be a square plus b square. And this is nothing but, this thing we have done in the conjugate, and this is nothing but modulus of z square. So keep in mind z into z bar. Complex if multiply with its conjugate, we will get modulus of z square. This is another property we should remember. Next property please. Next property says that if you have two complex numbers, if they are multiplied z1 into z2 and then I take their modulus, it will be same as modulus of z1 into modulus of z2. You multiply the two complex number and then take modulus, or you take their modulus and multiply, result come out to be same. But this is not valid for addition. Keep in mind, don't write this Z1 plus Z2. Modulus is equal to modulus Z1 plus modulus Z2. It is not valid. This is a wrong case. It is valid only for the product and for division. If it is Z1 by Z2 modulus, it will come out to be modulus Z1 by modulus Z2. That also you should remember.
Sir, and the mod of Z2 is not equals to 0 also we have to write, right?
Yes. Here in this case, Z2 should not be 0.
Yes. It should not be equal to 0.
Z2 cannot be 0 because Z2 if come out to be 0, it will become infinity. So that should not be there. And this condition is not going to be this. This is not going to be valid, not for plus, not for minus. That you should remember. So these are the properties we have done for modulus. Now we are coming on question again. Last time we have done the questions on standard form. Same thing, one more question I'll take on standard form, 1 or 2 questions. And after that we will come on some new questions. Write down please, first question. -2 minus 1 by 3 iota whole cube. I want the solution of it. Please solve it, bring the standard form. Bring this in standard form. In this case, what I should do first, a minus b whole cube formula. One thing I can do here in this case, this is minus, minus I can take common. Or you want to do it directly, you can do that also. A cube means what? Or better will be you take common, then it will be more clear. Otherwise minus mistake you will commit. First you will take minus common, then it will become minus here, and -1 cube will be what? Minus on the total. Then it come out to be 2 plus 1 by 3 iota. Now it is a formula of a plus b whole cube. Formula says a cube. Then comes out to be b cube. Then comes out to be thrice of a into b, and then 2 plus 1 by 3 iota. A cube plus b cube plus 3ab into a plus b. Now when you solve it, it will come out to be minuses here. This will be 8. This will be iota cube by 27. This 3 and 3 cancel out, so left is 2 iota. 2 iota multiply with 2. So it will left 4 iota. Then 2 iota multiply with this, so 2 by 3 iota square. Now when you solve it, it will be minus, it will be 8. Iota cube is minus iota, so minus iota by 27. Then I got is 4 iota, and this will be minus of 2 by 3. Now we'll collect the terms of real part separately, that is 8 minus 2 by 3. And then iota terms together, so iota it will be minus 1 by 27 plus of 4. Now when you solve it, it will be minus 8 3s are 24 minus 2 by 3. And here it is, iota is here, 27 is our LCM. So it will be coming minus 1 plus 27 into 4. Huh? 108. Now when you solve it, it will come out to be 22 by 3, first part. Second come out to be 107 by 27 iota. Minus you can bring inside and you will get your answer. Now coming on second type of question. Write down please. If Z1 is given as 1 minus iota and Z2 is given as minus 2 plus 4 iota. My question is, find out imaginary part of Z1 into Z2 by Z1 bar. I want imaginary part of Z1 into Z2 by Z1 bar. If Z1 is given, Z2 is given. Please try. Two.
Sir, my answer is coming 0.
Your answer is 0. Okay, check please. Z1 into Z2 by Z1 bar. First, let's start with this question. Z1 is 1 minus iota. Z2 is minus 2 plus 4 iota. 4 divided by Z1 bar. That is 1 plus iota.
Yes, sir. 2. Answer will be 2.
Yes, answer will be 2.
Excuse me, sir.
Yes.
अच्छा सर आप सॉल्व कर सर आई वाज सेइंग दैट इफ वी मल्टीप्लाई बोथ न्यूमरेटर एंड denominator by z1 bar then we can also apply that modulus formula.
Yes, you can do
So
that.
I'm having problem in
The
that.
denominator is there, but numerator you have to multiply. So it will come minus 2, then plus of 4 iota, then plus of 2 iota, minus 4 iota square, divided by 1 plus iota. Then this will be plus 4 now, and this is minus 2. So it is left 2 plus of 6 iota divided by 1 plus iota. So should multiply now 1 minus iota in numerator and denominator. Denominator come out to be what? 1 minus iota square, that will be 2 only. This will come 2 minus 2 iota, then plus of 6 iota, and then minus 6 iota square. When you solve it now, it will come out to be plus 6 now, so 8 plus of 4 iota by 2. Or I should say 4 plus 2 iota is the part Z1, Z2 by Z1 bar. And now what they are asking imaginary part of it. Imaginary part is only 2. So my answer come out to be 2.